All right. Well, good afternoon, everybody. It's good to see you. I hope you're having a good day so far. Just a couple of things before we go ahead and get started. I have a little bit of good news. There is no longer a fire drill during this class period today. So I know we were all looking forward to probably getting some fresh air, but for reasons that I'm not aware of, Mr. Anderson sent out an email saying that he had to reschedule it. So the fire drill has been moved to 2 weeks from now on February 23rd. So I'll definitely go ahead and make you aware of that, the closer we get to it. So we don't have to worry about that today. I want to go ahead. I posted information for next week. So let's see here. If anybody's interested in retaking the exam, you have until next Thursday morning. I don't believe that applies to anybody in here. Let's see. We just finished up linear functions. I think instead of doing that last problem, we're just going to go ahead and move on with quadratics. I know we had a quick review on quadratics prior to this. This goes into a little more detail about finding the vertex, maximum, minimum, things of that nature that we really didn't take a look at in the other one. But I'm going to go ahead and give you linear functions assignment. I'm going to go ahead and give you the quadratics assignment when we're done with it. So here's what we're going to do. The compound and simple interest homework is still going to be due on Friday, but I'm not going to go ahead and quiz you over that. I think what I'm going to do as an alternative is I'm just going to go ahead and give you the quiz so you can kind of see, what kind of questions would be asked, just to see how you're doing on it. Because I want to go ahead and keep going. We really don't have a lot of time, and I want to make sure that we have enough for a review prior to May when you take your paper exams. So as of right now, we'll talk about compound and simple interest come Friday. I'll just hand you the quiz next week so you can take a look at it, kind of get an idea of what you would have been asked. The linear functions assignment will be due Monday. The quadratic assignment will be due Tuesday. And that way we'll have a linear and quadratic quiz come Wednesday. And then next week we'll be able to start with right triangle trig, probably even get into law of sines, and we'll just keep going and see what happens. Now we've got just over 3.5 weeks until what? The IAs. Okay, so how many people are continuing to work on your IAs? Fantastic, fantastic. Remember, if you need any help, if you have a question, want me to take a look at something, please don't hesitate. But on Monday, March 7th, that is when the due date's going to be. Mr. Gonzalez and I are actually working out. I don't know if I'm going to go ahead and take the day off on March 9th or 10th. It's going to be either that Wednesday or Thursday, so I can go ahead and grade those. I'm pushing for Thursday. He has to leave early on Thursday the 10th, and I just want to make sure that everything will be taken care of. So I'll go ahead and let you know when that rolls around. What else am I missing? I believe that's it. A lot of information, but are there any questions? No quiz for compound and simple interest. Yeah, sorry about that. But next week, we'll have our next quiz on Wednesday over linear and quadratic functions. Okay, so what I'm about to pass out to you is the linear functions assignment and the notes for the quadratic review that Mr. Gonzalez is going to discuss with you. We were talking earlier, in fact, we talked about this yesterday. This is the only class that he hasn't really interacted with you or taught you yet, so we thought, why not go ahead and just get him in here? Jason, you had your hand up too. Oh, here's just stretching. Okay. Any other questions? How would do it? Okay. So with all that taken care of, now what would you prefer? Going to visit Mount Rushmore or visiting the Lincoln Memorial and the Washington Monument? Lincoln Memorial, Washington Monument? Okay. Okay. Why would you prefer that one? Okay. Yeah. True. Yeah. I've actually been to both the Lincoln Memorial and the Washington Monument. I've been to Washington, D.C. a couple of times, and I love that city. It's so nice. I spent a lot of my time there in the Smithsonian, but I did visit both of those locations there. Has anybody ever been to Washington, D.C.? Cool, very cool. Did anybody already visit that? Either of these locations? Okay. All right. Okay. All right. So anybody else? Would anybody say Mount Rushmore? Hey, wow. I I don't know. Mhm. Oh yeah, a lot of people. Mhm. He is sitting there. It's true. Yeah. Yeah. Okay. Tranquility of nature, seeing giant faces on a rock. Okay. Very cool. All right. Anybody else? All right. Well, with that, I'm going to go ahead and pass out those papers that you're going to need, and I will turn it over to Mr. Gonzalez.
All right. So, quadratic equations. So, quadratic functions are nonlinear and can be written as in the form of y equals ax squared plus bx plus c, where a is not equal to 0. It's called the standard form of the quadratic function. I'm sure you guys are maybe familiar, so we're just using this for remedial. So, parabolas are symmetric and they have a central line for the axis of symmetry, and it intersects at only one point, being the vertex. So, remember, parent function, y is equal to x squared. We have our standard form. The axis of symmetry, which cuts through the middle, and the y-intercept of c, whenever x is 0, it's in 6 and y-intercepts. And so for the vertex, because the axis of symmetry cuts down the middle and touches the vertex, your vertex is the x of negative b over 2a, and then whatever that plugs into for y. So if you're all familiar with that. And that whenever a is over 0, it's positive, so it's going up. Whenever it's less than 0, it's negative, so it's going down. They can't be 0, because then that would make it a linear function. So for this first one, let's plug in each of these x's. So y, start with negative 2 squared, minus 2, negative 2, minus 1. So negative 2 squared, what would that be? 4. Negative 2 times negative 2, plus 4, minus 1. So that would be 7. Same thing for negative 1. So negative 1 squared. 1. Negative 2 times negative 1. Minus 1. So we would have those two cancel. 2. And then what about 0? What would that give us? And what is that also? Which point is that for this function? No. If our x is 0, where's the point hitting? The Wait, no, that's other one, yeah. Yeah, the y-intercept. X0 is the x-intercept. Yeah. But yeah, so that's obviously c, as it was written up earlier. And so 1 squared, 2 times 1. So 1, 2, 1. 2, 2. So 4, minus 4, minus 1. Yeah, 3. So 3 squared, 9, minus 6, minus 1, that's 2. 4 squared. So 16 minus 8 is 8, minus 1, that's 7. All right. And so for the domain and range, so what will be the domain of this one? Yeah? Or is it all real numbers? How do you guys write it?
Actually, we can write it either way. In IB, they do like interval notation. But if you were to go ahead and put all reals or the double R, I don't think anybody would get all. I definitely wouldn't.
Or all real numbers. And then for the range, well, or actually, so what would be our axis of symmetry if we were doing minus b over a, 2a? So our b would be, what would it be? 2 or just 2? And then R2a. So what are AB? So negative times negative, so 2 over 2, be 1. So our axis of symmetry would be 1. And plugging it, and then since our axis of symmetry is 1, that means this is our vertex. So 1, negative 2 is kind of hard to see. You know where the center is, sir? This one?
Let's see. Yeah, it's kind of hard to see, but I believe it's that one. Yes, that's a little bit.
So 1, negative 2. If I can kind of get this right. So I guess what would our range be from there? Negative 2, infinity. Yep. You betcha. So, moving on. So figures that possess symmetry are those in which exactly half. So, one side, you flip it to the other, symmetric. Every point on the parabola to the left of the axis, symmetric to the corresponding point on the right. And with that, it's easiest to locate the vertex, which we kind of did from axis symmetry. So remember, to find the vertex, it's the minimum or maximum. If it's pointing upwards, positive, that means we have a minimum for our vertex. If it's pointing downward, it's our maximum. And to find the y-intercepts where it intersects the graph from the y-axis. So, I find parts parabola from the equation. So, I guess reading again, if a is positive, the parabola opens up and the vertex is our minimum. If a is negative, it opens down and our vertex is maximum. And to find the vertex, graph around your calculator and calculate the min or max, or axis of symmetry. So, actually, this is what we just said already. So, what would be the vertex for A? Robin, what would be the vertex for this one? Or let's start with the axis of symmetry. What would be the axis of symmetry first? Negative 2. Yep. And then Jason, what would be your vertex then? Negative 2. So that would be 8 minus 16, or plus 16. So negative 8. That would be 10, wouldn't it? So do you have the answer key for this one?
What are we looking for?
The vertex for this one?
Oh, got it right here. Let's see here. For 2A, I got 6.
Okay. 6. Oh, yeah. So, and then it's for the y-intercept. So, then for the y-intercept, what would that be? Okay. And then for the axis symmetry for B, what would that be, Omar? Omar? Okay. No more? We want to help him out with the, I guess, axis of symmetry. -1. Or, yeah. Say. Okay, and then for the vertex, so it'd be -1. What would it be for that one, sir?
For that one, you want to substitute it in? Show them how we can evaluate that?
Sure.
But for that one, I got the minimum to be -5.
-5?
Everybody agree?
So it'd be 3,
3
-6. Mm-hmm. So, okay. And the wider set? Okay. Now for this one, I probably want one of you to come up. So determine whether the function has a minimum maximum, state the minimum maximum, and state the domain range. So, Robin, would you like to come up?
Sure. Yeah.
So A is negative, L maximum. So B is negative, so it's positive on top. 2 times -1. So -1's our axis of symmetry. -1 times -1, so it's +2, -2. -1. So
that would be the y value, right?
yeah. Domain is all real, or negative infinity, positive infinity, and it works. So the range, if it's a maximum, negative infinity, -1. Yep. Yeah. All right. And then for the third page. So, graphing quadratic functions. So you guys are being reminded about a lot of the characteristics of quadratic functions. So enter into the Y screen. Find the vertex and plot that point on your graph, and you're able to find other points. So that one was like a Control T for that one, right?
Yes. So if you've already plugged it into the calculator, while looking at the graph, hit Control T and it'll split screen it from the table of values.
So example 4, graph of x, -x plus 5x minus 2. Is this where you would normally pull out the calculator, sir, for on the computer?
Yeah, I've got the calculator. Oh, actually, let me shut it down.
It's okay.
Close sort of graph screen. Okay.
Remember again, was this the one? This is the program that doesn't work with this.
Yeah, this is the new one, so it might look slightly different, but I think it's really close to what they have.
No, but like, could I not like tap on?
Oh yeah, you can. Yeah. Let me just make sure over here that mouse is on. Otherwise, it'll start drawing the marker.
So we have -x plus 5x, and C was -2. -2. Enter. And then from here, find out where the vertex is. So menu 3 and what was it? No, was it trace?
You could do it by trace. Analyze graph is typically where I go.
Okay, so minimum maximum. Okay, so yeah, minimum maximum, and then for Control T, when our table pops up. I'm sure you guys are a bit more familiar with like working out these calculator. So back to this. So Ben shoots out an arrow. The height of the arrow can be modeled by the quadratic function of y equals negative 16x plus 10x plus 4, where y represents the height of the feet in an arrow after x seconds is shot. So graph the height of the arrow. You just go back to the calculator, or try to write it here, or
Oh, why don't we do this one by hand? Yeah. I mean, you're definitely going to have a calculator when it comes to the paper exams, but I don't think it's a bad idea to be able to do these by hand as well. And we have plenty of time. Aren't we almost done?
yeah,
Yeah, we're almost done.
that's it. Last half of the papers. Okay. So negative 16x, 100x plus 4. So our b is 100 over 2 negative 16. So it's negative 100 over 32. That would simplify down to 2, 4.
What, 25/8?
25/8, yeah. So 25/8. Put that into.
So 3 1/8. That one, I'd probably go with a decimal.
3.125. So from there, that's the height of the arrow. So
that's where the maximum height occurs. There you go.
Well, for the y, I'm not sure I'd be able to calculate that with.
That one, that might not be a bad idea. Just to plug in the calculator, let it do the heavy lifting for us.
That one. There we go.
Okay. So let's go ahead and document B out of here. There we go. And now we have the scratch pad.
Okay. So negative 16. 5 squared. And it was plus 100x. Oh, yeah. I'm like trying to come down. There you go. 100. 5 plus 4. Actually. Okay. So 160, 125. All right, not bad. So 160, 25, meaning our point, 2.15, and here. And so what height was the arrow shot? So that'd be, what would that be for, in terms of our coordinates? So, y-intercept for that would be 4. And what is the maximum height of the arrow? Well, we kind of calculated already. So it was 160.25. All right. And then for our last exam.
If we could, sir, could we go ahead and also calculate where the roots are?
Roots?
Yeah.
In which case,
because on this one, I think we're definitely going to get a decimal answer, and I would just like them to see one that doesn't factor nicely, so we probably have to use quadratic formula.
Like working it out, or is there?
Yeah, let's work it out.
Okay.
So I kind of sprung that on you. If you want me to do it, I can do it, but if you feel comfortable.
Just, oh, wait, I forgot about it. There we go. So,
oh, and now
Okay. That's not what I want. Okay. So negative 100 plus root. So that was.
You might want to go ahead and change this here because I think it's going to read it as subtraction.
Is it? Oh, did I?
So let's go ahead and delete that. There we go. Okay. Just want to make sure about that. I think you. My bad.
Yes.
Oh, what did I do? I hit it. Yeah, because I'm not thinking. Oh, that's why. There we go. Now it's got the negative.
So 100 squared minus 4 times negative 16 times 4. So all over, well, that's not what I wanted. Negative 100 all over 2a, so 2 times negative 16. So that'd be our plus for that one, right? Then
now for the minus, what we can do is instead of retyping the whole thing,
yeah, so I was like,
arrow up and change
enter.
that one.
Mm-hmm.
That could potentially be a question asked in this type of problem. Even if you want to sketch it, you only need 3 points minimum, so the vertex and the roots would be perfect if you go ahead and do that. But how long was the arrow in the air before it fell back to Earth?
Oh.
That would definitely change.
But not actually.
It's
not working.
Okay, then let's try this.
There we go.
Okay, so how long was it in the air before it hit the ground?
Now, it wasn't explicitly stated, but x could be a measure of time. So how? It wasn't explicitly stated for this one. Oh yeah, x seconds.
So it took about 6.28 seconds after it was launched to go ahead and hit the ground. Okay, anybody need elaboration on the quadratic formula? Would anybody like to see the general formula? Okay, we'll go ahead and write that out.
Okay. So quadratic formula from. I didn't really write that down. Perhaps down here. So x is equal to negative b plus or minus for both our roots b squared minus 4ac over 2a. Or plus will give you the one root and negative will give you the other root, as you were kind of working out.
These are great. A lot of times you're going to be asked to go ahead and find roots and quadratics. In fact, IB does a really weird job. If they want you to factor something, they actually use the word factorize. I never heard of that until I got to IB. But not everything will factor nicely, and you have different options. Quadratic formula being one of them. You can also do completing the square. But I'm thinking quadratic formula is probably going to be the next most efficient method to finding those roots.
Okay. And so to finish it up, who would like to answer these questions? Let's come up as a board and try this out. Manish, would you like to try this? Answering these questions for example 6. For so what would A be, I guess? If Pass the Balkan model to negative x squared plus 8x plus 2. Which one would that be? So we have two things we can kind of consider. This one. So we have our axis of symmetry, so which cuts it in half, as well as our y-intercept for C. So out of those, which one would that be? That might be kind of hard to see. I mean, yeah, go ahead. I believe it's D. Since it kind of hits.
That one's a little hard to see.
Yeah, I was like, it's kind of hard to see, but it hits the 2 right there.
Not the best one. But at least on the other ones, you can definitely see that both B and C cross at 0,4, and A crosses at a negative value. So the only one that would work out has got to be D.
Mm-hmm.
I really like problems like this, but usually, I mean, tennis players make such an awful racket.
Okay. All right. So, Isaiah, would you like to come up and try B, I guess? Part B of this? The height. What height was the ball hit? Mm-hmm. So what started it off? What height was it?
In terms of the quadratic, how high was the ball before it was hit and followed this parabolic path?
And it's so basically when was x 0 seconds?
So at what height was the ball hit? Algebraically, they're asking you what was the y-intercept.
Two.
Because they're just taking that problem and putting it in context of the real world.
Okay. And Justine, what would C be? Clear stop. All right. I think that's all we had for today, right, sir? Yeah, it's literally 3 pages.
Yeah, the one the whole time. Okay.
Next will be their homework.
Yeah. Did anybody have any questions over anything we talked about? A lot of this is familiar. Again, another good old Algebra 2 installment. Alright. So, you got the compound interest assignment, which is due Friday. I just went ahead and gave you the linear functions assignment, which is going to be due Monday. I feel like I don't want to give you the quadratics just yet, because that'd be overload. I think what we'll go ahead and do is I can go ahead and give you tomorrow that class period to go ahead and work on your homework assignments if you have questions. And that way we can just continue and start right triangle trig done Monday. Unless you folks want us to move on. What do you think is better for you? Would you want the class period tomorrow to work on your assignments, or should we move ahead? Assignments? All right, let's do it. Thank you so much, but I will wait until tomorrow to go ahead and pass out the quadratic.